Hi everyone, this is question number 30 in chapter 2. So for this part, we need to solve the following problems related to stationary points. Stationary points or turning point, they are the same thing, just use the different terms. Okay, so remember at stationary point, our dy dx equals to 0. So we're going to use this all the time. So look at A, we have to find the coordinates of the turning points of the curve. So we have the curve given and determine the nature of each point. So in this case, let us, instead of using the product rules, I prefer to expand first so that I can differentiate much easier. So the x minus 3, when I expand it, I have x squared minus 6x plus 9. Therefore, I have x cubed minus 6x squared plus 9x. So from here, I can find my gradient function, that is 3x squared minus 12x plus 9. So for part A, at turning point, we know that dy dx always equals to 0. Therefore, 3x squared minus 12x plus 9 equals to 0. So quadratic comes, and we have to solve the quadratic equation. So to solve this quadratic equation, we factorize first, divide all both sides with 3. So we have x squared plus 4x. Sorry, that's a minus. Okay, minus 4x plus 3 equals to 0. And therefore, when we factorize this, we have 3 and 1 negative, both negative. Okay, so therefore we have x equals to 1 or x equals to 3. So we need to find the coordinates. So with this, we can find the y coordinates. So y equals to 1 cube plus minus 6, minus 6 times 1 squared plus 9 times 1. So over here we have 1 minus 6 plus 9. 4. On the other hand, y equals to, all right, so for this one, I will use this so that it looks much easier. So we have 3, and 3 minus 3 squared. This is 0, so 0 times 3 is 0. So our turning points are 1, 4, and 3, 0. Okay, so we got the turning points. Now we just need to check, determine the nature of the point. So in this case, our dy dx is this. So instead of choosing the sketching of the tangent, I prefer second order derivative because it's quite straightforward to differentiate it another time. Okay, so we will have 6x minus 12. So when x equals to 1, the second order of derivative, we sub 1 in, so we have a negative 6 less than 0. So it's a set phase. Therefore, this point, 1, 4, is a maximum point. Okay, and when x equals to 3, the second order of derivative equals to 6 times 3, 18 minus 12. We got 6 greater than 0. So that means getting bigger and bigger. The gradient from negative 0 to positive. So smiling face. If you equalize it with the coefficient of quadratic function, therefore 3, 0 will be the minimum point. Okay, that's it for part A. Now, let us move on to part B. So part B, it's not that straightforward. So we have to do something about it. All right. Now, so for part B, okay, let's get rid of this first. So for part B, we are given A equals to BH. With the condition b squared plus h squared equals to 40 and bh greater than 0. So we got to find the value of b and h so that A becomes a stationary point and show that the value of A is maximum. So how? So over here, we have A equals to BH. Huh? And since, if I want to find the stationary point of A, so we're going to determine A max or A minimum. So A will be extreme value, will be in extreme value when we differentiate A with respect to any one of the variable. In this case, let me just choose H. It will be equals to 0. So based on this, because at stationary point, you differentiate the quantity that you find the maximum minimum, you have to differentiate and let it be 0. So from A equals to BH, we replace the B with in terms of H. So since B squared plus H squared equals to 40, so B squared equals to 40 minus H squared. B equals to square root of 40 minus H squared. There's no negative because B value is greater than 0. So let's substitute that in here. So we have 40 minus H squared and the raised up to the power of half and then times with the H. Okay, so with this, we differentiate A with respect to H first. So we have to use the product rule, state V, differentiate the U. So when we differentiate the outside minus 1. So we have negative half. Okay, and followed by differentiate the inside. So we have negative 2H plus remain the U 40 minus H squared raised up to the power of half. Differentiate the V, which is 1. Okay, let's combine this and write properly. So we have the 2 and the negative 2 here. The 2 and the 2 can be simplified. So we will have negative H squared over 40 minus H squared square root plus 40 minus H squared square root. And let's combine this together. So find the lowest common multiple, square root of 40 minus H squared. When you multiply itself one more time, we will have 40 minus H squared. So over square root of 40 minus H squared. Open up the bracket. So negative H squared plus 40 minus H squared. So we have 40 minus 2H squared over square root of 40 minus H squared. So this is dA by dH. And at the turning point, we know that when dA by dH equals to 0, the 40 minus H squared can never be 0. Okay, therefore the one that contributes to 0 must be the one on top. So 40 minus 2H squared equals to 0. So 2H squared equals to 40. H squared will equals to 20. Therefore H will equals to 20. So we found H. Now we substitute this into B squared plus H squared equals to 40. So B squared, H squared is 20, so plus 20 equals to 40. Therefore, B squared must be equals to 20. And therefore, B is square root of 20. So we found B and we found H. And these two will make our A become a stationary point. And what is the value of A? So A is BH. So let's just take B times the H. Square root of 20 times square root of 20. So A value is 20. And we have to decide whether this is maximum or minimum. So how do we decide? We shall use the graph sketching method because otherwise we have to use the quotient rule. So it's more complicated. So let's just use the sketch of tangent to test it. Okay, so we use our variable is H and then dA by dH. Okay, and then sketch of tangent. All right, the H value will be square root of 20. So the value before square root of 20, let's find out what is square root of 20 first. So square root of 20 is 4.47. So let's just choose 4 and 5, before and after. And let us put in into our gradient function, which is 40 minus 2h squared. Okay, let's just put that in. So use the calculator. So we have 40 minus 2h squared. No h, we use x to represent it. 2h squared, and then over square root of the whole thing, which is 40 minus x squared. Close bracket. Okay, so what is the x? When x is square root of 20, you can check. It should be 0. Yes, we got 0. When h is 4, we got 1.63. 1.63, this is 0. What about when it is 5? So let's put 5 in. Negative 2.58. Negative 2.58. So the sketch of tangent, positive going uphill, negative going downhill. Therefore, the sketch of graph, we will get a set phase graph, right? Set phase graph. And therefore, we can make a conclusion that A equals to 20 is maximum value. Okay, that is question number B. Okay, next, part C. A piece of wire with length 120 cm is divided into 2 parts, where each is bent to an equilateral triangle with an edge of x cm. So let's just draw that triangle. This is equilateral triangle. The side is x cm, and the square. Another one is a square with the edge y cm. All right, and then the total length of the wire is 120 cm. So we have to express y in terms of x. So we know that 3x plus 4y will give us 120 cm. So since we need to make y the subject, so let's rearrange the equation. That will be 120 minus 3x, that is 4y. So to find y, the whole thing divided by 4. So we can write it like this, 30 minus 3 over 4x. So we have just written y, or we just leave it like this also can. I think we leave it like this now. Okay, now next, show that the total area of both shapes is given by this. So how do we find the area? So the area will be the area of the triangle plus the area of the square. Now the area of the triangle is half times the base. The base is x, and we have to times the height. So what is the height? Since this is an equilateral triangle, that means I can, when I draw the symmetrical line, it will divide the base into 2 equal parts. So that will be the height. So the height can be found by taking, by using the Pythagoras theorems. The hypotenuse is x, and the base here is half x. Therefore, the height will be x squared minus the x over 2 squared, and then we got to square root the whole thing. Square root this. That is the height. So half times base times the height. That is the formula to find the area of the triangle. Okay, and next, the area of the square, that will be y squared. Okay, so over here, let us simplify this one first. So we have x over 2. So x squared minus x squared over 4 and a square root. Okay, this side y squared. So we just put like this, 120 minus 3x over 4 everything we squared. So x over 2. So for this one, x squared minus x squared over 4, we change it to single fraction. We will get 4x squared minus x squared. So we have 3x squared over 4. And then on this side, now we have to compare. Keep looking at the final answer. Now the base is 16. I mean, the denominator is 16. And then I see 40 minus x here. That means I factorize this part. So let's just factorize the 3 out. So we have 3, 40 minus x. Now this whole thing supposed to square it. So we square the numerator and denominator separately. So 16. At the same time, I can square root of x squared over 4, which is x over 2. And inside left with Syd3. So plus, and then open up the square bracket. We have 3 squared, which is 9. And there's no need for us to expand this because in our final answer, I see this part, 40 minus x squared. So over 16. All right, now next, we have to simplify the first term. We have x squared over 4, Syd3, and then plus 9, 40 minus x squared over 16. So find the lowest common multiple, which is 16. So times 4 up and down. So we have 4 Syd3 x squared. And since denominator is the same, that is 16, so we can combine in this way. All right, isn't it this? Is the one given? So let's just rewrite the A so that it is in the same form given by the question. Therefore, A equals to 9, 40 minus x squared plus 4 Syd3 x squared over 16. We have just shown. Okay, done with this part. Now next we have to calculate the value of x so that the A has the stationary value. So when at stationary point, or you can use at turning point, dA by dx equals to 0. Okay, so let's differentiate this. We can take out 1 over 16 first. Okay, we differentiate the term inside. So bring down the power to the front, do outside, do inside. Yeah? So we have 18, 40 minus x, and then do inside. Inside is -1, plus bring down the power. So we have 8 Syd3 of x. Okay, that's equals to 0. And then we will, let's simplify this. So we have -18, I'll multiply this in. Okay, so we have 18x and then minus 720 and plus 8 Syd3 of x equals to 0. Okay, the 1 over 16 we bring to the other side. So 0 times 16 is 0. So over here, let's combine the coefficient for x. So we have 18 plus 8 Syd3 of x equals to 720. X equals to 720 divided by 18 plus 8 Syd3. So with the help of calculator, okay, so we have 720 divided by 18 plus 8 Syd3. So we got 22.6. So we found x to be 22.6. So the question is looking for, find the x So the A has a stationary value. So we found X, and we're going to determine whether this value of X make A a maximum or minimum. So we have to do the second order of derivative. So d2A by dx2. Okay, let's differentiate this part. Okay, let's rewrite our dA by dx properly. So we have 18 over 16. So 18 over 16, 40 minus x, multiply the negative in, so we will have x minus 40, and then plus 8 over 16, sub-3 of x. So before we differentiate, we make it more simplified. All right, so this one simplified, 9 over 8. So 9 over 8x minus, bring the 9 over 8 in, we have 45, and then plus 1 over 2, sub 3 over 2x. Okay, so we got to differentiate this. We have 9 over 8, and then plus sub 3 over 2. Okay, so for this one, two positive number when you add together, now we don't have to find the value. We know that this whole thing must be greater than 0. So when this whole thing greater than 0, therefore, we will have a smiling face graph. Therefore, A is minimum when x equals to 22.6. Okay, therefore, we found the answer for part C. Okay, determine whether this value of x make A a maximum or minimum. We already found. Now, let us move on with D. Now, for D, we have this diagram. It's a rectangle with a pair of edge length x cm, and the perimeter of the rectangle is 1 meter. So the whole thing is 1 meter, which means, let's call this y, okay? So we have 2x plus 2y. X and y are in cm, so this one must be equivalent to 100 cm. Make sure they are in the same unit, yeah? So y will equals to 100 minus 2x, and then divide by 2. So we have 50 minus x. So y is 50 minus x. We have to show that the area is maximum. So let's write the area. Area is actually x times y, and you have to make sure A is written in one variable. So let's substitute the y with 50 minus x. Therefore, we have 50x minus x squared. Our objective is to show that the area is maximum. So the area is maximum, okay, A maximum when differentiate A with respect to with its variable equals to 0. That is the reason we have to write A in just one variable, not two. So dA by dx is 0. So we differentiate the A with respect to x. So 50 minus 2x equals to 0. 2x equals to 50. Therefore, x equals to 25. We need to show the area is maximum if the shape is a square. So when x is 25, y is 50 minus 25, we got 25. Okay, so over here we have to, but we are not sure whether it is maximum or minimum. We need to check. Okay, so we have to decide if this contribute to maximum. Probably we don't write maximum here. A maximum or minimum when we set the turning point to be 0. Okay, therefore we check second order of derivative. We got -2, which is less than 0. When it is less than 0 means it is decreasing. So from positive to 0 to negative. So our graph will look like this. From positive gradient to 0 gradient to a negative gradient. That's why I keep reducing. You got negative value. Therefore, our A will be maximum when x equals to y equals to 25. So we can make a conclusion. A will be maximum when the shape is a square. the shape is a square. So that's it. We have just shown we have just answered the question. Show that the area is maximum if the shape is a square. So that's it for question part D.